if we have, all right, so we're going to continue on here. If we have a line which crosses over another line at some distinct point, okay, so, or, sorry, if we have a line that crosses over two other lines at distinct points, I'm just going to kind of label these here. We'll call that point A and this one point B. We call that a transversal. Okay, so a transversal is a line which crosses over two other lines at distinct points. It's not where three lines would meet, that wouldn't be a transversal, but this transversal here crosses over these two lines right here. Now, that can help us with some of the, with proving some of the angles if we know one other thing, and that is if these other two lines are perpendicular. I'm going to give a couple more letters here. I'm going to call this W, X, Y, and Z. Okay, so if we have line segment WX and line segment YZ, and if they are parallel, okay, we have some other proofs that we're going to go through in just a little bit on parallel lines, but we can show using little arrows that these are parallel. Okay, so this means parallel lines. Now, I often use two. Okay, you can also just use one as well. So if you just used one, you could do that as well. We could go one like that. Okay, represents parallel lines. If we have more than one set of parallel lines in a drawing or in a diagram, then one would have one arrow on it, one would have two arrows on it, and if there's a third one, we could have three arrows, and so on and so forth. These just represent they are parallel. So we know that this line and this line must be parallel based on what is proven in this example here. All right, so let's move on to looking at corresponding angles in parallel lines. Okay, and this is exactly looking at parallel lines. You'll notice the little arrow markers, they're a little bit off there. I might have to adjust my notes. But we say that angles in the same relative position at the vertex formed by a transversal are called corresponding angles. So if we take a look at the area that is by the transversal, this area right here, and now again, this is based on these being parallel lines. This area here, A, B, C, and D, is going to be exactly the same as this area right here, E, F, G, H. And because they're parallel lines, because this is a straight line transversal, these four angles are going to be exactly the same as these four angles. So angle A is going to equal angle E, B is going to equal F, C is going to equal G, and D is going to equal H. Okay, so that's what we have right here. Okay, so again, if these lines are parallel, and now here's another way to describe it, two solid lines that go upright. Okay, it's not two eyes, it's what we would call parallel lines. Then these corresponding angles are equal. Okay, and we can prove that. Okay, it's proved by corresponding angles. Okay, due to the fact that we have parallel lines.